Hello everyone and welcome back to Tesla Harmonics. Today I want to continue looking at Module 26304-23, Hazardous Locations in the NCCER 11th edition. This will be Section 2.00, Preventing Ignitions and Explosions. The following three basic conditions must be satisfied for a fire explosion to occur. A flammable fuel must be present in sufficient volume. The fuel must be mixed with oxygen in the air in a proportion that forms an explosive mixture, and a source of ignition must ignite the mixture. Warning: gas concentrations above the upper explosive limit are less likely to ignite, but that does not provide any degree of safety. The concentration must first pass through the explosive range to reach the upper explosion limit, and a change in concentration can quickly place it in the explosive range. Explosion-proof equipment and seals. Conformity with NEC requires the use of fittings and enclosures approved for the specific hazard. Explosion-proof equipment is rated by both classification and temperature. Never interchange fittings or covers between one hazardous location and another. Intrinsically safe equipment. Intrinsically safe equipment is incapable of releasing sufficient electrical energy to cause ignition of a hazardous atmospheric in its most easily ignited concentration. The use of intrinsically safe equipment is primarily limited to process control instrumentation because these electrical systems have low energy requirements. Installation rules for the intrinsically safe equipment are covered in NEC Article 504. Here's an example of a typical floor plan for a hazardous area. In hazardous locations, NEC Section 344.28 requires 3/4 inch taper per foot for threaded conduit. Metric or MPT threads are used. All connections must be made with 5 threads fully engaged and wrenched tight to prevent sparking when fault current flows through the system. All boxes, fittings, and joints in hazardous locations must be an approved type listed for the location. NEC Section 501 outlines the requirements for seals and drains in hazardous locations. In humid or wet locations, when moisture may enter the conduit system, the raceways should be inclined towards a low point with integral drains wherever possible. If raceways cannot be inclined towards a drain, special drain/seal fittings can be installed. Seal-off fittings must be selected for a specific class, division, and group of the hazardous location. Seals are available in a variety of shapes and sizes for different applications and mounting locations. Poured seals must be made following manufacturer's instructions for the fitting in use. Ensure that the sealing compound is compatible with the packing material, type of fitting, and the conductors used in the system. On large jobs, dozens of seals may be required. Seal hubs are often painted a certain color to indicate that they have been packed. A different color paint is used once the sealing compound has been poured. Here are some trade terms you should read over and become familiar with for this session, and some review questions for this session. Which of the following statements related to the ignition of combustible mixtures is true? Heat by itself will not produce an ignition without spark. Volatile vapors will not cause ignition if diluted below the lower explosion limit. Electrical hazards are unlikely to cause ignition. Sparking metal tools are unlikely to ignite a mixture because it is so short-lived. That's going to be B. Volatile vapors will not cause ignition if diluted below the lower explosion limit. Explosion-proof equipment is rated by both classification and weight, volume, pressure, or temperature. That's going to be D, temperature. Alright everyone, that was it for that session. The next session will be review for the module test. We'll do that in the classroom, and I'll see you